Unang araw pa lang minahal na kita. Bakit ba ganito ang aking nadama? Di man
Jum! Jum!
Oh, hey man.
It's the one and only Digo Double G.
Will you please help me?
Okay. So, what's that?
This.
A problem? A girl dropped a book at a height of 1 meter. How long does it take the book to reach the ground? So this is in our physics class, right?
Yes.
This problem is a free fall problem.
How did you know?
It's just easy, bro. Because it said that the book was dropped and not thrown. So in that case, it did only fall without a force reacting to it. So it was only free fall.
Oh, that's why.
So do you have the given yet?
Yes, it's in the second part.
Oh, okay.
Yes, we have the given, but we don't know still how to solve.
So the question was asking for the time. So time is equals to. So time is what we're gonna find. Oh, here's the formula for the time.
Yes, we have the formula, but still we don't know how to do it.
It's just easy, bro. You just have to follow the formula and substitute the value of the given.
Ah, okay.
So time is equals to square root of 2 multiplied by the height over the acceleration due to gravity. So 2 multiplied by the height, which is 1 meter, divided by the acceleration due to gravity, that is 9.8 meter per second squared. And then you just have to solve it in your calculator.
Oh, you have a calculator.
Oh yeah, I always bring a calculator with me.
Damn! You're like a real genius, man.
Oh, thanks, bro.
2,000 years later.
So 2 times 1 over 9.8 is equals to square root of 10 over 7, or we can have the decimal, which is 0.45 seconds.
Wow, you're so amazing, man. Thank you very much.
So the time the book reached the ground, it takes only 0.4 seconds with the height of 1 meter. That's all, bro.
Thank you very much, man. You're
mga mata at ang takot kung sakali mang ika'y mawala. At ngayon, nandyan ka na, di mapaliwanag ang nadarama.
Jum! Jum!
Oh, Matt.
It's and only Digo Double G.
We have another problem.
What's that, Matt?
Look.
Also, this is number 2. It's just related to the problem a while ago, right?
Yes.
So, what is its speed just before hitting the ground? So, in this case, it is asking for the speed. Or, you can also term it as the final velocity.
Yes.
So, given height is equals to 1 meter, acceleration due to gravity is equals to 9.8 meter per second squared, while its initial velocity is equal to 0, and the time, which we solved a while ago, is equals to 0.45 seconds. So what is its final velocity or its speed just before hitting the ground? So, the formula for getting the final velocity is equals to initial velocity plus acceleration due to gravity multiplied by time.
And 3 weeks later.
It was at this moment that he knew. He fucked up.
So, V initial velocity is equals to 0.50 meter per second plus the acceleration due to gravity, which is 9.8 meter per second squared, multiplied by the time, that is 0.45 seconds. So 0 plus 9.8 multiplied by 0.45, so 0, we can cancel this one.
Oh.
Oh yeah. Okay. 0 has no value, so it won't matter anymore, Matt.
They ask you how you are, you just have to say that you're fine when you're not really fine, but you just can't get into it because they would.
So 9.8 multiplied by 0.45 is equals to 4.41.
So,
2 hours later.
So the final velocity of the book just before hitting the ground, or its final speed before hitting the ground, is 4.41 meter per second squared. So Matt, we're gonna find the final velocity of the book. So final velocity is equals to initial velocity plus acceleration due to gravity multiplied by time.
oh.
So that's the formula, dude. So initial velocity, which is equals to 0 meter per second plus the acceleration due to gravity, 9.8 meter per second squared, multiplied by the time, which we solved a while ago, 0.45 seconds. So in this case, the initial velocity is 0, so we can just cancel this out. Because it won't matter if we add this one, because it's 0. It does not have a value. So 9.8 multiplied by 9.8 multiplied by 0.45 is equals to 4.41. 4.41, and our unit will be meter per second, because
Meter per second, but why not squared?
this will be cancelled out because it is multiplied by the second here.
Oh, that's why.
So the final answer will be 4.5 meter per second. That's the final velocity of the book just before hitting the ground.
Oh, thank you very much, Jom. You're
Okay,
very
okay.
helpful.
Oh, no problem, Matt.
Batang pasaway at lahat sa
Ang programang ito ay rated SPG. Striktong patnubay at gabay ng magulang ang kailangan. Maaaring may masiselang tema, lengguwahe, karahasan, sexual, horror o droga na hindi angkop sa mga bata.
As usual, I'm the earliest in the class again. Oh, we have an assignment. A man fell on the ground from a 2-story building. It took 3 seconds for the man to reach the ground. How tall was the building? So this problem was asking for the height. And probably this is a free fall problem. So, to find the height of the building, I've got 3 formulas that I can use. Height is equals to final velocity plus the initial velocity over 2 multiplied by the time, or height is equals to final velocity squared minus initial velocity squared over 2 multiplied by the acceleration due to gravity. And lastly, I can also use this one. Initial velocity multiplied by time plus 1/2 acceleration multiplied by time squared. So, let me guess, I should start with this one. But, first, I need to find the final velocity. Final velocity is equals to initial velocity plus acceleration due to gravity times time. So, the initial velocity of the man was 0 meter per second plus the acceleration due to gravity, which will always be 9.8 meter per second if it is free fall. 9.8 meter per second squared multiplied by the time, which is 3 seconds. So let's solve this one.
Day 2, day 4. A few inches later.
9.8 multiplied by 3 is equals to 29.4 meter per second. So the final velocity of the man, or its speed just before hitting the ground, is equals to 29 meter per second. So I've got the final velocity, so I can use this first and second formula. So the first, height is equals to final velocity, which is 29.4 meter per second plus the initial velocity, which is 0 multiplied by the time, which is 3 seconds, over 2, so equals 0.1 meters. So the second formula, 29.4 meter per second squared minus 0.0 meter per second squared over 2 multiplied by the acceleration due to gravity, 9.8 meter per second squared. And then cancel this one, is equals to 44.1 meter. Oh, so I'm starting to see the pattern or the answer. So the third, height is equals to initial velocity 0 meter per second multiplied by the time 3 seconds plus 1/2 acceleration due to gravity 9.8 meter per second multiplied by the time, which is 3 seconds squared. So cancel this part, is equals to 44.1 meters. So therefore, the height of the building is 44.1 meter. I've come up with the same answer using the 3 formulas, so therefore this is correct.
It's the one and only Digo Double G.